So this is the Oreo cookie lyase experiment. I'm doing a video on this just because of the fact that this will be relevant when we talk about inhibition. So cookie lyase is an Oreo or an example of an enzyme that twists Oreos apart. I credit Dr. Funkhauser with this. He was an instructor that I taught for as a graduate student, and I thought this is just fantastic. I think it's a clever way of explaining a concept. Now, what we were seeking to do was we were seeking to figure out the kinetic parameters of this enzyme, of this Oreo cookie lyase. And so what we did was we did a total of 9 trials. And we looked at number of Oreos per desk and number of Oreos lysed in 10 seconds. And so if you think about a number of Oreos lysed in 10 seconds, you could think about this as basically a rate. So number of products generated in a given time frame. Then if you looked at number of Oreos per desk, you could look at this in terms of concentration. So one of the things that we had control over, and you have control over whenever you are exploring the kinetics of an enzyme, is that you can control the concentration. You can adjust that. That is a variable that you have control over. You can increase it or decrease it. Now, in this, we did a total of 9 trials. And over those 9 trials, we increased our concentration of Oreos. And what we observed was an increase in the number of Oreos lysed in 10 seconds. I'm going to highlight a total of 3 different points as kind of our extremes. So when we had a very low number of Oreos per desk, 1 Oreo in 5 desks, we got 3 Oreos lysed in 10 seconds. When we had an even number of Oreos in a given per desk, we had a total of 10 Oreos that were lysed, or 10 products that were generated. And then finally, when we were more than saturating, so when we had 5 Oreos per desk, we got only 16 Oreos lysed. And if you look at the previous 2 data points, so 3 and 4 Oreos per desk, you had 15 and 15 Oreos or products generated. So what that tells you is that you had a diminished return as you increased your concentration. Now that is all displayed graphically right here. If we look at our y-axis, that again is our rate. And our x-axis is number of Oreo cookies per desk. You could look at that as your substrate concentration. Now what this shows is as your substrate concentration increases, well, so does your rate. However, one of the things that happens is if you look at this, this, and this, so our last 3 data points, they're comparable to one another. If you continued this on, the idea is that you would get not really much more of a return if you went on to 6 or 7 or 8 Oreos per desk. So at some point, we have a saturation effect that our substrate provides. So you can only increase the rate so much before you've provided more substrate than you need. Okay, so to take that same data, we generated a double reciprocal plot. So number of Oreos per desk, we took that 1 over 5 and we did 1 over 1 over 5, which got us 5. This 1 over the number of Oreos lysed in a second, that's going to be 1 over 3 or 0.33. So this data right here, we did 1 over that and that gave us this column. This data right here, 1 over that, and that gave us this column right here. So this is all that needs to be done in order to convert Michaelis-Menten data, or data from a Michaelis-Menten plot, into data for a Lineweaver-Burke plot. And ultimately, what that data looks like is this right here. I bring this up and I show you this because of the fact that I think that it's a good way to, and an easy way to, show the conversion from Michaelis-Menten data to Lineweaver-Burke data and plottable Lineweaver-Burke data, but also because of the fact that we're going to be looking at this graph. And this graph right here is kind of our foundation for discussions of different types of inhibition. So this plot right here, I just drew a line kind of parallel to the trend that our data shows. It's a linear representation. Now, we can use this plot right here to come up with our Km in our Vmax, but we'll do that in another video. At any rate, I hope this was helpful. I hope that this was something that you recalled from our lecture. All right, well, thank you very much and have a good one.